Hello and welcome. This is going to be our lecture video for April 2nd. Going to be talking about some word problems today. Goal is to practice word problems involving sequences and series, as well as a few calculator skills. This is going to help get us ready for our quiz coming up and maybe give us some math that we could use down the road as we are doing things like trying to decide what kind of raises we want, which is exactly what our first problem is about. So let's imagine a situation where your current job is paying you $45,000 a year, and your employer is offering you two ways for your salary to increase over time. If you haven't already, go ahead and get your notes out, put today's date, April 2nd, up at the top there, copy down the relevant information from this setup. So you can either take a 2% raise every year or a $1,500 increase every year. And what's making this problem unique is that I want to consider every single year. I don't want to just worry about final salary. I want to worry about how much money I'm actually going to make in total. So often a problem like this is taught in a unit on exponents, and they only focus on final balance. I want to focus on how much money total would we make, including like the money you make year one and the money you make year two. So that's why we need our series formulas, and we actually have a geometric series here with the 2% every year. That's going to be geometric. And we have an arithmetic series here with the 1,500 increase every year, because so the 2%, that's a common ratio. 1,500, that's a common difference. So this one is arithmetic. All right, so for our, we'll call the 2% pay raise every year, we'll call that plan A. It's the 2% raise. The total amount of money we're going to make is going to be determined by our geometric series formula, which is the amount of money we make the first year times 1 minus our rate raised to the power of n being the number of years, over 1 minus r. Let's fill in the numbers that the problem gives us here. Our initial value is 45K. The rate, this is actually kind of tricky. Some people just plug in a 2 there or a 0.02. It needs to be 1.02. And the reason for that is that each year I'm getting 100% of my previous salary, that's what the 1's for, plus an additional 2%. If we didn't do that 1 in front, then our salary would actually shrink to be only 2% of its previous value every year. 1.02 gets us an additional 2%. So we get the 100% of our previous salary plus an additional 2%. Okay, so here we've got a good expression for plan A. For plan B, this is the plus 1,500 every year. And the formula for the sum of an arithmetic sequence is, well, the way I like to do it is you take the first and the last term, you average them, and then we multiply by the number of terms. All right, and this one's going to get a little bit more difficult because we've got n appearing twice here. We need, maybe off to the side, to use our formula to get a sub n. So this is our explicit formula. A sub n is the first term plus our common difference times n minus 1. All right, so let's plug in, we'll plug in this for a sub n, and we'll plug in the values from the problem for everything else. Okay, this here equals 4,500 plus 4,500. I'm plugging in right here now. Let me just draw an arrow here so we see where this is going. Plus our common difference of 1500 times n minus 1 all over 2, and then there's an additional n down in front. Let's simplify that down a little bit. Keep doing that. And we get 90,000 plus 1500 times n minus 1 all over 2 times n. We could simplify more. We could distribute this. We could distribute the n. I'm going to call it good there and get out my graphing calculator to figure out when these are going to be equal. So I'm going to use the y equals to plug these equations in, starting with my geometric one. 1 minus the rate, 0 to the power of, we have to use x for our variable, but we'll just know that that stands for n, divided by 1 minus 1.02. Let's just look at the table for this one real quick. So, your table set start at 0 years, and go up by ones. All right. So at the end of 1 year, we've got $45,000. At the end of 2 years, we have an additional $45,000 plus that the raise increase. That's where the extra 900 came from. But because we constructed the formula this way, we don't have to add anything. That's telling us how much money we've made over our lifetime. Let's just scroll and see when we make $1 million. If you follow this raise structure to get 19 years to make over $1 million. So hopefully, you're also doing some investing so that you can make your first million a little bit quicker. But if we just relied on that 45,000 plus the raise every year, it's going to take us 19 years to make $1 million. Okay, into y2. Let's plug in this other formula. So it was 90,000 plus our common difference times x minus 1. All of that was divided by 2. So let me make sure I do my parentheses right here. So we're averaging effectively our first and our last paychecks and then multiplying that whole thing by the number of years. And let's go back to our table and see how that's going to change. So let's double check that at 0 years we have $0 with both of these. Yep. So 0 years we have $0 with both of them. After just 2 years, Plan B is looking superior. We've got $91,500 in the bank to this $90,900. Well, let's see if that holds true forever. Let's see, Plan B still beating Plan A. They make their first million after 18 years, while it took this plan 19 years. Is it ever going to catch up? Yeah, Plan B is still superior here. Thought they would catch up a little bit quicker. Okay, wow. Okay, so after 70 years, Plan 1 is still inferior to Plan 2. If you work for 70 years at this job, you've made $6.7 million. This one here, also $6.7 million. After the 71st year, you'll have 6.93, or really 6.92 8 to their 6.922. So 71 years is the break-even point. And after that, we should see that Plan A really does outpace Plan B. I'm a little surprised. I mean, I just made up these numbers. I thought Plan A would catch up sooner. Let's see if we're able to work some ridiculous number of years like, well, here's a good benchmark. Here's your first $10 million, takes you 86 years. And then Plan B doesn't make their first 10 million until 90 years. Okay, so I think we can go back and fill this stuff in. So, Plan B is superior until 72 years. Therefore, I would pick Plan B here. You really do end up making, I mean, you're never going to work a job for 72 years. So even though this 2% will eventually catch up to this 1,500 a year increase, it takes a really long time. And all that money that you made in previous years is really what's adding up and making Plan B superior here. Okay, that was a long problem. So, on to a problem about a football player named Alan. So Alan has to maintain a passing grade of 60% in math to stay on the football team. On the first math quiz, he scored an 84. On the second, he scored an 80. On the third, he scored a 76. If this trend continues, how long until Alan is ineligible? So what kind of trend do we see here? We got an 84, then an 80, then a 76. This has a common difference. He's doing an average, or exactly 4 points worse on each quiz. And so we're trying to see if this trend continues, how long until he's ineligible. Now, recognize this is not the same as asking how long until Alan scores a 60% or worse on a test. His grade is going to be the average of all of these. So we just sort of need to borrow a kind of a point from our sum of an arithmetic sequence formula and say that the average of two numbers is them added together divided by 2. We want to figure out when this average here equals exactly 60%, and then we'll say once we go above that in terms of number of quizzes, then the percentage is going to drop below 60. Okay, so let's plug in an 84 here. And we don't know this, we'll just use an x here. So 84 plus x divided by 2 equals 60 times 2 times 2. 84 plus x equals 120 minus 84 minus 84. X equals 36. Let me double check that. We got 120 minus 84, 36. So what this is telling us here is that Alan's not going to be ineligible until the day after he scores a 36 on his math quiz. So this is A sub n. And it's because all of these original quizzes are kind of building up a good percentage for Alan. He then needs to start scoring below 60% and doing it consistently until that average gets brought down below a 60. So now that we have A sub n, let's use our explicit formula to solve for n, the number of quizzes that's going to get us there. So A sub 1 plus d times n minus 1 equals A sub n. So 36 equals 84 plus our common difference of negative 4 times n minus 1. And now let's just solve for n. So I'll subtract 84 from both sides. 36 divided by, or minus 84 equals negative 48. So negative 4 times n minus 1, divide by negative 4, divide by negative 4. (48 over 4 is 12, so 12 equals n minus 1, add 1 to both sides. And so 13 equals n, but be careful here. So it's on the 13th quiz that's Alan's percentage is going to drop down to a 60%. So really it's after his 14th quiz that he will become ineligible. Because right at 13, he's just barely still eligible to play football. At the 14th quiz, he becomes ineligible. Okay. Next question is about a bouncing ball. Suppose you drop a tennis ball from a height of 15 feet. After the ball hits the floor, it rebounds to 85% of its previous height. How high will the ball rebound after its 8th bounce? So normally our formula, this must be a geometric sequence, because each time it bounces, we multiply its previous height by 0.85, because we're multiplying by 0.85. Common multiple or common ratio means geometric formula. So normally you just take your initial height and you multiply it by the ratio to the n minus 1. But this isn't going to exactly work for the 8th bounce, because the 8th bounce is the 9th height. So I'll let you think about that. So we start at 15. All right, 15 is our first height. It's multiplied by 85%. So 15 times 0.85 is 12.75. So that was one bounce, but we're on to our second number. So this formula will work as long as we remember to plug in either a 9 here or just an 8 for the exponent. And not do 8 minus 1 and then do a 7 here accidentally. So this is going to be 15 times 0.85 to the power of 8. Just plug that into our calculators. 15 times 0.85 to the power of 8. Do not press enter before you say to the power of 8, because the exponent has to come first in the order of operations. And we get 4.087 feet. All right. So I think I got just 2 more, and these times I want to use, for both of these, I want to use the calculator to actually plug in the sigma notation. Anyway, so we've got a display of cans on a grocery store shelf that's set up in a pyramid that's got 20 cans across the bottom, 18 cans in the next row, and so on, and then it stops when there's 4 cans on top. So it kind of looks like this. We've got some cans arranged in a pyramid, but we stop when there's 4 on top, so maybe I'll add 1 more on the bottom here. All right, so you got cans in a pyramid. Write an expression in sigma notation, express the total number of cans in the display. All right, so we are going, let's figure out a formula for the number of cans in each row. So if it starts with 20 in row 1, then the number is going to be 20 minus 2 times x minus 1. So you take the row number. In the first row, the row number is 1, so 1 minus 1 is 0, and this goes away. And what we're doing is we're subtracting our common difference of 2 that many times. So let's figure out how many rows we're going to need to get this to be equal to 4. So I'll just set this equal to 4 and solve. Subtract 20 from both sides. Negative 2 times x minus 1 equals negative 16. Divide both sides by negative 2. X minus 1 equals 8 plus 1 plus 1. X equals 9 rows. All right, now I want to borrow this for my sigma notation. So I want to do the sum from I equals 1, so from the first row up to the 9th row of 20 minus 2x minus 1. All right, so there's our sigma notation. We can now use the formula for the sum of an arithmetic sequence, but I want to show you how to plug this into your calculator. There is a way to do this. There's actually two ways to do this. I meant to clear my calculator. Okay, here we go. So one way is we press math and we look for this summation button. Here now we can plug everything in. I can say I want it to start at x equals 1. I know I wrote this with an I there, but it works better with an x. Also, I guess if I put an I there, I should have put an I there. Let me swap this one to be an x. I think it'll make more sense. Okay, so I can just start filling in from x equals 1 to 9 of 20 minus 2 times x minus 1. All right, and I get 108 cans. $108 cans. Let's double check it with the algebraic way of doing this. So we could say the first row had 20, the last row had 4, so I'm going to average that by doing 20 plus 4 divided by 2, then I'm going to multiply by the number of rows, which was 9. Let's do this in our calculator. 20 plus 4 divided by 2 is 12, times 9 also gets me 108 cans. Okay, if your calculator doesn't have this fancy sum button, you can still find sum under catalog. So you have to go second, 0 for catalog. Press the green S to go jump right to the S's. And I want to sum. Oh, it's way down there. Maybe it would have been faster to jump to T first. I want to sum, and then we go back into the catalog, second 0, go to S again, the sequence, and here's where we can plug in our sequence. 20 minus 2 times x minus 1. Then we're going to use a comma, declare our variable as x, and say we want to go from 1 to 9. I think every parentheses matched there. I think I need one more. And we get 108 again. So that's pretty tough. You know, I'm not expecting you guys to do that in the quiz or anything. Just wanted to show you that it is possible. All right, let's move on. Last one. A new shopping mall records 130 total shoppers on their first day of business. Each day after that, the number of shoppers is 12% more than the number of the shoppers the day before. Write an expression in sigma notation to find the total number of shoppers that visit the mall for the first 14 days. I actually borrowed this one from a Khan Academy one. If you want to do more problems like this, I'll link it on the calendar. But here we go. So I'm summing from x equals 1 to 14, because I want to add up all the visitors from the 1st to the 14th day, of our initial amount, 130, times our common ratio. Again, we have to do 1.12, so we get 100% of the previous amount plus an additional 12 to the power of x minus 1. All right, let's plug that into our calculator, see what we get. So I wanted to do math, the sum from x equals 1 to 14 of 130 times 1.12 to the power of x minus 1. All right, and see, it's just so much more powerful than asking how many visitors visited on the 14th day. This gives you all of the people, total number of people that visited in those 14 days, 4,211. And we'll round to the nearest person. 4,211. All right, let's check that this would have worked with our formula, which is take the first number, do 1 minus the ratio raised to the power of n divided by 1 minus the common ratio. Let's plug this into our calculators. 130 times parentheses 1 minus 1.12 to the 14th, close parentheses, divided by parentheses 1 minus 1.12, and I get exactly the same number, 4,211. All right, and I guess we should say people or shoppers, give it some sort of unit. Okay, you can just keep working on the review for the quiz. No other homework for today, and have a good rest of your day.